So in the last video we were having a small discussion about the string matching algorithms, and I told you that majorly there are four major string matching algorithms. Number one is the naive string matching algorithm, then the second one is the Rabin-Karp algorithm, then we have finite automata based algorithm, and then we have Kruth-Morris-Pratt, that is KMP algorithm. So in this video we will start with the discussion about the string matching algorithm, which is a naive string matching algorithm. Okay, so assuming that we have the following array, this is the array that we have, and this array is having some characters. See, strings are array of characters in case of C language, right? In case of C language or C++, you can strings are mutable. When I'm saying mutable, that means you can make changes to the string. But when we discuss about Java, in case of Java, the strings are immutable. That means you cannot make changes to a string. Rather than whenever you make a change, then a new string is defined, a new memory area is defined, and then you give the address of that memory area to that particular variable. So in Java, strings are implemented using classes, but in case of C++, strings are implemented using arrays because they are array of characters. So assuming that we have the following data which is present: A, B, C, A, D, A, C, D, D, B, C, A, and D. This is the array that we have, and this array is representing the array of text. This is representing the array of text, and we'll be having an array which is representing the pattern. That means what is the pattern that we want to search in this particular array. So assuming that the pattern that we want to search is B, D, B, and C. This is the pattern that we want to study. Now your job is to write an algorithm. Your job is to write an algorithm which can find out where is that base address of that pattern, where this pattern is actually located in this given text. And see, generally the text is generally very huge, very large, and the pattern is also very large. But here, for simplicity, we are taking a very small pattern which is only of 4 characters. In the same way, we are taking a very small string which is having a few characters only. That is for simplicity purposes. Okay, so here, assuming that these are the index locations 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and this is 0, 1, 2, and 3. Okay, so as I told you that we have multiple algorithms. Number one is the naive algorithm that we are going to implement here. Naive, or you can say it is also the brute force technique. Brute force technique. What is this naive algorithm or the brute force technique? You are going to take this pattern and you are going to compare with every location. Okay, that means initially what you will do is you are going to take this given pattern and you are going to compare it with the first 4 locations, right? So if it could not match the first 4 locations, then you are going to take it and match it with the second 4 locations. Then if it is you cannot match it, then you are going to take it and match it with the third, 4th locations, and so on. So you are going to match it with every possible location into this given array. But the problem with that is, assuming that the length of this array is n, that means if you are having total n characters in the text and you are having total n characters in the pattern, then in worst case you have to search from the beginning. Every index location you have to search, and every time when you are going to perform this one, then in worst case you are going to match the m-1 characters. That means if we have a string like this, B, D, B, A, B, D, B, 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 D, B, C, and so on. Now here in this case, if you are going to match it with this one, then you are going to see that first 3 characters are matched, then the 4th one is not matched. Then you identified your mistake. In the same way, the first 3 characters are matched, then the 4th one is not matched. The first 3 characters are matched, 4th one did matched. So in worst case, if you are going to search this pattern to this text using naive string matching algorithm, then it is going to take order of n minus m plus 1 into m as the time complexity. This will be the time complexity of this algorithm. So when I'm going to implement it as a function, then you will be able to understand how we are getting this time complexity. Okay, so let us try to figure out an algorithm based on this one. You can follow the given topic from the book, which is Corman. So Thomas H. Corman is there. So you can use that book where there's a special chapter which is dedicated to the string matching algorithm. But you are only going to get a algorithm implementation for the string matching. You are not going to get a programmatical or program implementation for the string matching algorithm. So for simplicity, so we'll try to implement this here. How you are going to take it? So we'll be making a function and assuming that this is matching function. Okay, this is a matching function, and this function is going to take both text and the pattern as input. So it is going to take character array text, or you can just say instead of character array as text, you can simply take character text as an array like this, and you can take character pattern as an array. These are the two things that you need to find out. Okay, now what you have to do is you have to match this pattern with every location of the text. Okay, for that purposes you have to take a loop, but you first need to find out what is the length of this text and what is the length of this pattern, and assuming that in the last location we are storing null values. Okay, you can do it like this. Okay, now I need to write down a function to find the length of both the text and find out the length of both the patterns. But for simplicity here, I'm just assuming that we are passing those length and pattern into this array. So that is integer n comma integer m, where integer n is the length of the text and integer m is the length of the pattern. Okay, now we have to run a loop. So for that loop we are going to take integer I and j as two variables, and as well as we are also going to take a flag variable. So integer flag is equal to 0. That means when we find out that this pattern exists, then we are going to come out of this one. Okay, then we have to take for I is equal to 0. That means from this index location, from the starting index location, you have to go to every index location. Okay, so I'm trying to make it as simple as possible, but while implementing we may do some changes. So we are just first of all trying to figure out how should we implement this particular algorithm. So what we have to do is we have to take the first location here. We have to take the first location, and then we have to try and match this particular pattern. Now if you can see, with the first location is A and the patterns containing B, obviously A and B are not matching, then we have to come out of this matching loop and then we have to continue. Otherwise and then we have to go to the next location and find out the pattern. Okay, so let us assume that we are taking flag is equal to 0, correct? So for I is equal to 0, I less than n, and we have I plus plus. Okay, so here we may need to fill out some conditions later on, so that is why I'm keeping this space as empty. Now after you enter into the first loop, then we have to make sure that the pattern is matching. So we have to make j for j is equal to I, that means from whatever the location is I is, because initially we are going to take I into this location and we are going to match with this first location of j. Now if it is not matching, then we have to take I into this location, and again we have to match with the entire pattern. If it is not matching, then we have to take this with I and we have to match with the entire pattern, and so on until we find out the index location. So I is working on the text and j is working on this pattern. So in any way, if we are going to cross j to the fourth index location, that means we found the pattern and the entire string is matched. So we are going to take j is equal to I and j is less than m, and we are going to take flag is equal to 1, correct? So for that purposes, let us assume here, oh sorry, yeah, so correct, so let us assume here I'm going to take flag is equal to 1 for that purposes. So assuming flag is equal to 1, okay, and flag, just instead of flag is equal to 1, then you just have to write and flag, and then you are going to make here j plus plus if, okay, this text of I plus j. Okay, so you have to take if text of I plus j is equal to pattern of j. Okay, then we have to make flag is equal to 1, else flag is equal to 0. Flag is equal to 0. Okay, so here in this loop we are trying to see if this first character is matching, if this one is matching with this one or not, if this one is matching with this one or not, if this one is matching with this one or not. If they are not matching, then we are going to make flag is equal to 0, otherwise we are going to make flag is equal to 1. So we have to make if text is equal, text of I plus j is equal to pattern of j. Why I'm saying I plus j? Because every time we have to increment in the text also. For example, if text is initially I is at this location, next time we have to make I to go to the next location. That depends on the value of j. Okay, so correct. Right, so either I can take text of I plus j, or I can also make some changes here, because what I have to do is, instead of starting j from this location, so let us start j from 0. So if we start j from 0, then I can easily write text of I plus j is equal to pattern of j. And after this for loop, if j is equal to m, then we can say pattern found. Then we can say printf pattern found, and we can return the index location of that location. Okay, so here we can return the index location. Okay, return index location. But if we could not find the pattern, then we have to say printf pattern could not be found, and we can just return back to the main function by saying that we cannot find the pattern, so that will be maybe -1, and so we have to make the this location as integer. Okay, return type as integer. So this is the algorithm that we are going to implement. Okay, so now let us start in the next video. Let us try to see how we can implement this algorithm for finding out the pattern in a given text. Okay, so let us move on to the next video about after this one.